Hello, students. Welcome back to Chemistry with Ms. Hernandez. Today we're covering section 6.20, periodic trends for ionic radii. Okay, and we are working with the CK12, but instead of working like we usually do, we have a pair deck. Okay, and my students, they should be joining us. Why do I only have one student, guys? Let's go. Join the pair deck. I only have one person in my pair deck. Let's go. Let's rock and roll. Hi, guys. So this is the same CK12 that you see on the website, except I've just made it into a PowerPoint, and it's a lot more better this way. Okay, I got a lot of good feedback from the last time we presented this way. So we're going to do it again. Hey, Irvin, join me in the pair deck. I've already posted the link in the chat. All right, let's get started. All right, who's going to help me read? How are peanuts sold? How are peanuts sold?
I'll do it, miss.
Thank you, Irvin.
First paragraph, right?
Yes, I will help you with the second one.
Peanuts can be sold two ways. The bare peanut without the shell brown inner protection of peanut can be purchased in jars and packages for casual munching or for cooking. The size of the peanut in this situation is smaller than the peanut plus shell, since the other portion is missing. If we add to the peanut, we have larger size for the combination.
Thank you. All right. Thank you, Irvin. So they're talking about peanuts with and without the shell. Obviously, if it doesn't have a shell, that size is going to get smaller, right? If it doesn't have the shell. If it does have the shell, you're going to see an increase in the radius of that peanut, right? You think, oh man, with the shell, man, this is going to be a big peanut. And then you open it up and it's this little peanut on the inside. That's the way it works, okay? Electrons and protons are strongly attracted to one another. The strength of that attraction and the relative numbers of the two particles in a given atom or ion have a significant influence on the size of that species. When an atom loses one or more electrons, the resulting ion becomes smaller. If electrons are added to an atom, the ion becomes larger. So do you kind of see why they use the peanut example for our introduction? Well, remember, if you are an atom and you have given away an electron or an electron has been removed from you, you're going to be like that inner peanut where the radius is a lot smaller. If you are an atom that has gained electrons, you're going to be like that shell, right? It's going to be a bigger size, a bigger radius, okay? That's how come it's part of our introduction, because we are comparing the size of those peanuts to when atoms gain and lose electrons, okay? Now, here's the topic, ionic radius, okay? Ionic radius. Ionic radius, the radius for an atom is measured in a crystal lattice, requiring a solid form for the compound. These radii will differ somewhat depending upon the technique used. Using X-ray crystallography, usually X-ray crystallography is employed to determine the radius of an ion. Okay, so anytime you're trying to find the ion radius, you need to be in a solid form, and it needs to be in a crystal lattice. Okay, and what is a crystal lattice? Look at this right here. This right now is salt. This is a crystal lattice for salt. So this is sodium and chlorine. And anytime you're talking about a crystal lattice of an element, instead of having two different colored marbles like you see here or spheres, you're only going to have one color. Okay, meaning there's only one type of element or atom in this crystal lattice. Okay, this is what they use to find the atomic radius for elements when they lose or gain electrons. Okay, so keep that in mind when we're talking about today. Now, here, if you look at the table, you will notice that you're comparing the size of an atom. You're comparing the ion sizes to atom sizes for group 1, 2, 13, 16, and 17. Hold on. We can see a little bit better. Okay, the atoms are shown in gray. Groups 1, 2, 13 are metals and will form cations. Cations are going to be in red. Groups 16 and 17 are nonmetals and form anions, and you can see them in blue. So the gray, guys, the gray is the original atom before it has lost or gained electrons, okay? The ones in red and blue is what happens when you lose electrons, is what's in red, and when you gain electrons is what happens when you they're the ones in blue. Okay, hold on. You want to get off? Okay. So if you're talking about group one will have a tendency. Hold on, Mama. Will have a tendency to lose one electron. Okay, hold on, guys. Let me continue recording. All right. So group 1, you can notice in gray was the original, and once it's lost one electron, that size has gotten smaller. So it was a pretty decent size, and then as it loses, it's going to become smaller. Now, if you're in group 2 will lose up to 2 electrons. Okay? So that size will get twice as small. Okay? When it comes to group 13, they will lose up to 3 electrons. Okay? So it's going to get small. It's going to get smaller when it loses that second. And when it loses that third, it's going to get even smaller. Okay? So if you lose electrons, you will reduce the size of your atom. Now, let's look at the opposite. Let's look at groups 16 and 17. These elements will have a tendency to both gain electrons. Okay, these groups will gain electrons. And anytime you gain an electron, your size of your radius of the atom or the ion will become larger. Okay, so in gray again is the originals. In blue are the ions. This is when those elements have gained electrons, and you can see that radius is getting a lot bigger. Okay, it's getting a lot bigger. All right, now let's compare group 16 to group 17. Now group 17 has only lost one electron, so that size will increase, but not by a lot. Group 16, on the other hand, it gained 2 electrons. So it's going to get bigger. And then when you get that second electron, it's going to get even bigger. And you can notice that the size difference it's pretty big. It was 73. It ended up at 126. Here you had 71. It ended up at 119. So this one is a little bit smaller than what you have for group 16. And the same thing happens here for period 2, or for period 3, I'm sorry. Here you have chlorine. It used to be 99. It went to 167. Sulfur started off at 102 and ended up at 170. That is bigger than what you see for group 16. Okay? Now, you got a question next. Are you ready? Are you ready? There's a question coming up. Let's see if you guys can figure it out. If I can see. Okay. All right. So it says here, let me just move this out of the way. Drag your dot to indicate whether you agree or disagree with the statement. The atomic radius, and this is a definition that you had on Monday, and let's see how much you remember from Monday. The atomic radius is defined as 1/2 the distance between the nucleus of identical atoms that are bonded together. Do you agree with this statement or do you disagree? What do you think? Okay. Do you agree or do you disagree? I got 3 responses out of 6. I got 3 responses out of 6. And if you're not in here and you want to join us, I'm putting the link again. Okay. Let me get one more response from you 6, and then we will reveal our answers. Okay. All right. There we go. Oh, we got a lot of green. A lot of people are agreeing, and we got one person. I'm not really sure if you disagree or not, but you're kind of in the range that you do disagree. Okay. All right. Are we done? Do I have any more votes before I continue? There's supposed to be one more person. Oh, look at that person. All of a sudden, they changed their answer. That's great. So the atomic radius is, that statement is correct. It is 1/2 the distance between the nucleus of the same atom. Very, very good. Good job, guys. Great job. I knew you guys were super smart. This group, I got some really, really smart students. All right. So now we're going to talk about when elements gain electrons. I'm sorry, wrong. I take that back. This is what happens when electrons are being lost. And it even says here, you're losing electrons. This is the original. This is what you get afterwards. And if you'll notice in the picture, there are 3 electrons and 3 protons. They are equal, right? What happens after you lose an electron? Who becomes in charge? Protons or electrons? Who's in charge? If you are a group of athletes and you're going against another team and you got 3 members in your team versus only 2, who's going to be in charge? Is it going to be the proton group or is it going to be the electron group? What do you think? Who will be in charge once you lose 1 electron? And you can just go ahead and post it in the chat or you can come off mute. Who is in charge of this atom? Who is going to be the winner in this case? Electrons or protons? After you lose electrons, who do you have more of? Who do you have more of? Protons or electrons? Very good. Oscar is saying protons in the chat. Excellent, sir. You are correct. In the case of a cation, protons are in charge. Well, what's the charge of a proton? What is the charge that we're looking at for protons? What kind of charge are cations going to have? What is this? And it's not the sign of the cross. What symbol is this? What symbol is this right here that you're looking at? Protons are positively charged. Cations will be positively charged, okay? Now, let's read. The removal of electrons always results in a cation that is considerably smaller than the parent atom. When the valence electrons are removed, the resulting ion has 1 fewer occupied principal energy level, so the electron cloud that remains is smaller. Okay? Another reason is the remaining electrons are drawn closer to the nucleus because the protons now outnumber the electrons. One other factor is the number of electrons removed. One other factor is how many electrons are being removed. The potassium atom has 1 electron removed for the corresponding ion, while calcium Group 2. Remember, potassium is group 1. It lost 1 electron. Calcium is in group 2. It's going to lose 2 electrons. It's going to be twice as small. Okay? You got a question. Are you guys ready? Are you ready? I'm going to let you look at this page real quick before I ask your question. Because, let's see how you do. You ready? You ready? I think you're ready. Is this statement true or false? Cations gain electrons. Cations will gain electrons. True or false? I got no responses yet. I got one response. Come on. What else? What else? What else? What do I got? What do I got? I got 2 responses, 3 responses. I don't want to give out the answers just yet. I want to know what you guys think before. I got 4 answers. If you're not in the pair deck, you should be posting in the chat. Let's see. All right, let's see these 4 responses. If they chose true or false. Uh-oh, it's a split decision. I need somebody to break the tie. Do cations gain electrons? True or false? I need one more answer. All right, now I got 3 people that say it's true. Uh-oh, they went back. Pick one, guys. You need to pick one. Anybody else want to vote in the chat? You can vote in the chat if you don't want to do it in the pair deck. I need one more vote, guys. I need one more vote. Anybody who's in the pair deck, come on. There's 6 people in the pair deck and I only have 2 responses. Where's the other 2 people? All right, that's better. Okay, I got 3 people saying that's true, 2 people saying that's false, and the correct answer is it's false. The answer is false. Cations don't gain electrons, guys. Cations don't gain electrons. Cations lose electrons, okay? Now we have 6 responses. Oh, now everybody's saying, you guys are funny. You guys are so funny. Okay, one more, true and false. Is this statement true or false? Cations have a positive charge. Cations have a positive charge. No responses yet. One response. Come on. Who's gonna help me out here? One response. I need more responses. Cations have a positive charge. I got 3 responses. Okay, I need at least 1 or 2 more responses before I reveal the responses. Come on, guys. Okay, I got 4. I need 1 more response. 1 more person needs to vote. True or false? 1 more person needs to vote. True or false? Cations have a positive charge. 3 people said true. 2 people said false. This time, you are correct. The 3 people who chose true, that's correct. Remember, the plus looks like a T. Always remember that T is for positive, okay? That's why I was doing that. I was kind of hoping you would get it because I kind of mentioned it the other day, but only 3 people remembered. Very good, guys. Very, very good. Awesome. You guys are great. Now, let's talk about anions. Anions are the opposite of cations, okay? Cations lose electrons. Anions gain electrons. Cations are positive. Anions are negative, okay? Anions are negative. And I always think of N and anion for negative, okay? So here you have a picture. Originally, there was 3 and 3. Look at that. Now I have 4. So who's going to be in charge here? Those negative electrons. What kind of charge will anions have? N for negative. N for negative. Okay? Let's see what happens. The addition of electrons always results in an anion. Okay? So anytime you gain electrons, you're going to be called an anion. And in an anion, it becomes larger than the parent atom. So anytime you gain electrons, electrons are going to repel. That's going to make your radius bigger. Okay? So here, you were probably about here before you gained it. You come here once you have gained that electron. Okay? Those electrons are going to push the cloud to become bigger. When the electrons outnumber the protons, the overall attractive force that the protons have for the electrons is decreased. The electron cloud also spreads out because more electrons results in a greater electron-electron repulsion. Notice that group 16 ions are larger than group 17. The group 16 elements each add 2 electrons, while group 17 adds 1 electron. Okay? So group 16, why is that group bigger? Because group 16 didn't add 1 like group 17, they added 2. So group 17 will be here, group 16 will be here because it's got more electrons, it needs more space. Okay? There's a question. Are you ready? And this one's typing. This one's not true or false. You actually have to write something. Tell me anything that you can. Okay? Check this one out. Give me one statement about this picture. Write anything. And it could be something basic. It could be something, whatever it is that you can remember about this picture. Okay? What can you say about this picture? Okay, and I have one person who has responded. I need at least 5 people to respond so that we can look at what they said. And you can write whatever you want about this picture. Anything that you notice about it. Okay? Anything. Just write something, guys. I only have one person writing. Where are the other people? You can write anything. Okay, I got 2 people writing. Excellent. I need at least 3 people more. I need 5 people to come up with something about this picture, and it could be anything. You can say protons are red, electrons are blue. I don't care. Just write something. I only have 2 responses. 3 responses. Good. I need at least 2 more responses. I need 5 responses before we move on. Come on, guys. I only have 3. Tell me anything about this picture. Come on. Anything. What can you tell me about the picture in front of you? Anything that we discussed. I want you to write it out. All right, let's check it out. Why did you delete your response? Guys, anything is correct. It's losing protons. Did we lose protons? That one, that might not apply. In a cation, there are 3 valence electrons. In an anion, there are 5 valence electrons. That's a good one. That's a good statement. Whoever wrote that, that is an excellent statement. Okay, guys, when it comes to atoms, protons don't move. If you would have said it's losing electrons, I could have taken that. Okay, so I would fix this one. Okay, no, you shouldn't have deleted. Just change it to electrons. Okay, All right. Good job, guys. Good job. Okay. Whoever did this one, excellent job. Write your name so we know who did this one. Okay. I want to know who did this one. Write your name in there. Who did this one? Miss America. Awesome, America. You did awesome. That is a really good statement. Really, really good. Awesome. All right. You could have said that cations are negative. You could have said, anions are negative, cations are positive. You could have said anything like that. You could have said one atom has more electrons than the other. Anything, guys. We're going to be doing this a lot more, and I'm going to need everybody to be responding, and you could say anything. You could have even said the protons are red, miss, and the electrons are blue. That's a true statement. Okay? Don't be afraid to type, guys. Don't be afraid to be wrong, okay? I can always help you fix your answers, okay? But I need you to type something so that I can help you fix it. All right, we got a video. Where should I put myself? Okay, I guess I can put myself over here.
Ionic radius. Ionic radius refers to the radius of anions and cations. So instead of atomic radius, when we're talking about an atom that has a neutral atom that has all of its electrons and protons, we're actually talking about, when we talk about ionic radius, we're talking about the radius of anions and cations, positive ions and negative ions. So what we notice here is that metals tend to lose electrons, forming positive ions. So their ionic radius is smaller than their atomic radii, because when you lose those electrons, it's easier to pull in the remaining electrons, so those electrons are pulled closer, making the atomic radius smaller. So for a metal, let's say Na, if Na is big, when it becomes Na plus, its atomic radius gets smaller. So it moves from this size to this size when we're talking about its ion. Nonmetals tend to gain electrons, so they form negative ions because now they have gotten more negative energy, so now they're more negative, and their atomic radii are larger than their atomic radii because when you add more electrons, it's easier for them to spread out because the attractive force of the protons isn't as much on those new electrons. So if I had this as, let's say, Cl, now Cl is going to become bigger because it has gained a new electron. It's going to be Cl negative. And so it moves from being smaller to being bigger. And we can see this if we look at the periodic table. We're going to notice that the metals on this side, they're going to get their ionic radii get smaller. So they're going to be much smaller here than they were before. And they're in the nonmetals where they are attracting more electrons. Their ionic radius is bigger. So we have to remember when they ask you about relative size of ionic radius that you have to remember the comparison between atomic radius, knowing that ionic radii are smaller here because they lose electrons, and here they are bigger than usual because they gain electrons.
Alrighty, so let's finish up our topic for today.
Ionic radius.
Sorry. All right, so in summary, ionic radius is determined by measuring the atom in a crystal lattice. Our second point today was removing electrons results in an ion that is smaller than the original parent atom. Anytime the addition of electrons results in an ion that is larger than the parent atom. And then you have your review questions. How are ionic radii measured? Number 2, explain why the radius of rubidium is smaller than the radius of a rubidium atom. Number 3, explain why the radius of tellurium is larger than the radius of a tellurium atom. And number 4, why is oxygen anion larger than a fluoride anion? Those are the questions that you're going to be answering.